So let's look at an example of surface area where we need to find the surface area of a square pyramid. So Marie made a model, as shown below, of the square pyramid she plans to build when she grows up. And we need to find the surface area of this model. So a square pyramid, notice that the base is a square, and each of the side lengths on the base are all going to be 8 meters long. And it's a pyramid because all points on the edge of the base reach up and meet at one point above. So we need to find the area of all of the outside of this pyramid. Since remember, surface area is just the total area that all of the faces occupy when you add them together. So for this problem, we would need to find the area of this bottom square face, and since it's a square, it's going to have four different triangular faces. You have this one here, and then based on this picture, it's a little bit hard to see it, but there's a triangle on the back side there, and then there's a triangle right here. So essentially, we have four different triangular faces, and we have the base. And so if we can find the area of each of those, we can just add them together. But let me draw another picture of this square pyramid just so that we can get a little bit different perspective on what they look like because, again, it's hard to see two of the faces here. And with this picture, it's not drawn exactly like this. The lengths are going to be different, but you can at least see that there are four different triangular faces. You have the one in front, you have the one on the right side, the one on the left side, and then there's one triangular face on the back. So you do have those four triangular faces, and you have the base of this shape. So to find the surface area, we need to find the area of each of those faces and the base, and then add them together. So we can write out that the surface area for a square pyramid, we will find the area of the base, and we're going to add that to 4 multiplied by the area of we can say, triangular face. And we can just multiply that by 4 since each of the 4 faces are going to have the same area. They are all going to have a base of 8 meters and a height of 5 meters. Since with these square pyramids, there's a lot of symmetry. Essentially, if we look at the height of any of these triangles where we can draw a vertical line down and make a right angle, each of these heights would also be 5 meters. So on each of these faces, we end up with the identical triangles. So let's start calculating what this area would be equal to. So let's say SA for surface area. It's equal to the area of the base. So that's a square. So let me draw that out. We have a square where each side length is going to be 8 meters, and we just have one of those. And from there, we're going to add the area of the triangular faces multiplied by 4. So we have 4, and let me draw in a triangular face here where each of these faces has a base of 8 and a height of 5 meters. So we need the area for a square or a rectangle. That is just the length multiplied by the width, whereas the area of a triangle, remember, is half the base times the height, and we can use b and h for that. So for this one, it's just going to be 8 times 8, and we'll use the proper units, so 8 meters times 8 meters. And then we have 4 of these triangular faces. So it will be half the base, which is 8, multiplied by the height, which is 5. And with all that, we now have our equation, which we can simplify. So our surface area will be 8 times 8, that's 64. And we have meters squared, because we have meters times meters. And for this next part, we have 1/2 of 8, that's 4, times 5. We have the 4 on the outside. So 4 times 5, that is 20, so we get 20 square meters. And lastly, let me just make a little bit more room here. So 64 square meters plus 80 square meters, that is 144 square meters.